Now that we all have a better handle on speed and understanding how to use the equation and how it's present in experiments like the cart rolling down the ramp, we're going to talk a little bit more about what velocity is. So we're going to finish with 4.1 speed, position, speed, and velocity today. This is part 3. And your learning goals are, you'll have 3. The 2 on this one are explain the meaning of motion and tell the difference between speed and velocity. I'd also like you to have this one. Tell the difference between a scalar and a vector. So, position is going to use positive and negative numbers. As we kind of know, when you're moving around, if you look in the number line on the bottom, you'll see the ant. If the ant is to the left of the origin, he has a negative position. If it is right of the origin, he has a positive position along that number line. So position is showing us 2 things. It's showing us how far away, so a number value, and it's showing us direction. We'll talk about that in a second. Now, distance, as we've said before, distance is only going to be either a 0 value or a positive value. So the ant moving around, you can see in the bottom left, not moving has a distance of 0. The ant moves up to the left, 4 centimeters, to the right, 3 centimeters. It's only how far. You're just saying how far the ant's going from one spot to the next. So these are something known as scalar and vector quantities. Let's take a look at this on the board. So there are scalars and there are vectors. And what a scalar is a quantity or number that is fully described by magnitude alone. The word magnitude means how much, a number value. So distance is going to be an example of a scalar because it only tells you how far. It only tells you walked 20 meters, or it's 30 miles away to the nearest store, I don't know. Only a number value associated with it. A vector is going to be a quantity that has both magnitude, how much, and direction, in which way. And that's very, very important in understanding which way things are moving. And it's extremely important in physics and physical science when we're trying to understand how things operate and how things move. This is part of being able to understand or explain the meaning of motion, is being able to describe which direction things going in. And this is going to come much more into play when we get into other variables like force later in the year, or acceleration, which we're actually going to get into very, very soon. So, scalar, magnitude, how much? Vector, magnitude, and direction, how much and which way. Let's create a table that shows this, that shows a few variables, and whether or not they're scalars or vectors. So we've already worked with a couple of things, distance and position. Distance, as we just said, is a scalar, so we're going to put it on the scalar side. Distance just tells us how far. Only magnitude. Doesn't tell us anything about which way we're going. And as we already know, distance is abbreviated with a lowercase d. Now, position would be the vector, because it's going to tell us where we are in which direction relative to an origin. But I'm going to introduce a new term. I've said it a couple times in class and said we'll get to it. And that's the term displacement. You can almost hear it in the word, displace. Where is your place? And if you get displaced from it, you're moving in some direction away from your original placement. You're displaced. So, displacement is the equivalent to position. How far are you away from something and in which direction? And the variables or the letters that we use for this are, I'm going to put it, let's see, there. a triangle symbol with an X or a triangle symbol with a Y. That triangle is called delta. So the name for this triangle is delta. It means change in. So, almost speaks for itself. Change in the X direction. Change in the Y direction. That's why displacement is abbreviated with these two. They represent change in the X or change in the Y. We're going to be using that delta symbol all year long. Whenever you see delta, a triangle, change in. There's a change happening. So distance, displacement. Those are our two right there. To show you an example really quick, let's just slide over here. So for an example, to understand distance versus displacement, the scalar of distance versus the vector of displacement. Let's say that you start at an origin, some random point, some random position in space, and you go north, maybe, I don't know, 4 meters. You go west, maybe about 3 meters, and now you're at a new position. Well, your distance is the total of how far you went. 4 meters plus 3 meters. You went a total distance of 7 meters. That's your distance, only how far. Your displacement is where you are relative to your original spot. So here you were, here's your origin, here's your new position. That red arrow represents your displacement. Let's write it in red. And we can go into the mathematics about this a little bit in class, but for now, can any of you tell me what math I used to figure this out? Tell me in class. The overall displacement is going to be 5 meters northwest. So do you see how with the scalar of distance, it's the sum of the total ground covered, and it's just a magnitude. How much? The vector quantity of displacement is how far relative to your origin in a straight line over. 5 meters in this instance. And which way? Northwest. Northwest. So it's entirely possible that you could go up, down, left, right, sideways, backwards, forwards, all which way around the world, come back to your original position and have a distance of thousands of meters, but a displacement of 0. Because it's how far are you away in which direction from your original spot. So let's go back. Now 2 more are going to be a scalar of speed, which we've already worked with. Speed is going to tell you how fast something's going to go, but that's it. It's only going to tell you how fast. It's not going to tell you which direction the object is moving. So we've abbreviated speed with V, but I'm actually going to change it now. We're going to use S. Speed is S. I've decided I'm okay with that. The other term, the vector quantity that relates to speed, is velocity. Velocity is our vector quantity. V. V for velocity. Velocity means how fast and what way. So, similar to speed, saying that velocity is speed and direction is almost correct, but it's not entirely true. It is not entirely true. It would only be true in some cases, because velocity is going to be overall the change in displacement over time, while speed is the change or how far distance over time. It's very important to know that your speed is your distance over time. So the sum of every which way, you don't care about direction, where velocity is your change in displacement, your overall change in displacement as time has progressed. We're going to work on this in class. Might be a bit confusing, but it'll make sense as we move on throughout the year. As far as today goes, it's just important that you know the difference between a scalar and a vector. Scalar, how much; vector, how much in which way. And that distance and speed are two scalars. Displacement and velocity are two vectors. These are related to each other. These are related to each other. They're similar to each other on either side, but they are not exactly the same. And in order to fully understand motion and be able to explain what's going on, we need vectors in science. We need to say which way are things moving, what direction are things going. And it's going to become very, very important as we progress in the year. So I'll see you guys in class. Bye-bye.